let's look at a similar example. Let's look at the question, what are the solutions to 4 times sine squared of x minus 1 is equal to 0? So before we start, we need to remember a few things. First of all, we can use the unit circle to our advantage. Specifically, we want to use the points of the unit circle, so the x, y coordinates are cosine of the angle and sine of the angle that define the point. And lastly, we want to use the periodicity of the function to solve for just a finite range and then extend it. So in this case, since we're talking about sine is the only trig function in here, we're just going to solve from 0 to 2 pi, and once we find those solutions, we can extend them to all of the real numbers. So let's go to the board. So here's our equation. And what we want to do is we want to solve for this trigonometric function here. We can use the unit circle whenever we have sine of something is equal to a number or cosine of something is equal to a number. So what we want to do is reduce it to that case. So the first case is just to treat this sine squared as a variable and try to solve for this. So what do? We do the typical things. If this were just a big X, we would add 1 to both sides and then deal with this 4. So first we have sine squared of x is equal to 1. Again, because we always move over constants first. And we're still not done. This trigonometric function is not alone, so we have to get rid of this 4. Since it's multiplied by sine squared of x, then we have to divide by it. So therefore we just have sine squared of x is equal to 1/4. So now here we're in a little different case. We're not used to seeing sine is equal to 1/4, and that's actually correct because this is sine squared. So what is sine squared? It's really just sine of x, whatever that value is, and then we square it. So this is what's really equal to 1/4. So how do we ordinarily solve for something squared is equal to something else? We take a square root. So the square root of this side is just sine of x. And then we have to take the square root of 1/4. And we also have to keep track that since we are squaring this number, it could either be positive or negative. In either case, we get a resulting positive number. So we have to include plus or minus. Now when we're taking the square root of 1/4, we could just take the square root of the top and the square root of the bottom. And what we get is 1/2 or 1/2. So therefore, our solutions from 0 to 2 pi, and actually in general, are going to satisfy that sine of x is equal to positive half or negative half. So let's break those into two cases. Sine of x equals positive 1/2, and sine of x is equal to negative 1/2. So let's figure out what the x value is, and first let's just look from 0 to 2 pi. So that's the solutions we're going to get here. So we're going to get a solution over here and a solution over here. So let's use the unit circle. So here we have the unit circle. So one of the things we were looking for is that sine of x is equal to positive 1/2. So sine is the y coordinate. So we're looking for a y coordinate having 1/2. So let's just get a ballpark on where it should be, ish. So here is height 1 and here is height 0. So 1/2 is right in the middle. And it looks like it's right about this spot and this spot. And sure enough, if we check with our unit circle, sine of pi over 6 is the y coordinate, which is 1/2. And sine of 5 pi over 6 is also equal to the y coordinate, which is 1/2. So therefore, we have those two solutions. So far we just have pi over 6 and 5 pi over 6 for the positive case. Now let's do the negative case, same way. We're looking for sine being negative 1/2, so we want the height to be negative 1/2. So it's right about here, and it looks like it's about this point, And sure enough, both this y-coordinate and this y-coordinate is negative 1/2. So what are those angles? Well, it's going to be 11 pi over 6 and 7 pi over 6. So let's write those down. So right here, we have all the solutions to this original equation when we're looking just from 0 to 2 pi. So now what we want to do is extend to everything. So if we're going from 0 to 2 pi and sine is 2 pi periodic, all we have to do is tack on this plus 2 pi n term, where n is any integer, everywhere. And plus 2 pi n, where n is an integer. So now that we tacked on these, here is one set of solutions, here's another set of solutions, here's another set of solutions, and another set of solutions. And since we extended this, we're no longer talking about just from 0 to 2 pi. We have every possible solution. So therefore, all of our solutions to 4 sine squared of x minus 1 equals 0 are all numbers of the form pi over 6 plus 2 pi n, 5 pi over 6 plus 2 pi n, 7 pi over 6 plus 2 pi n, or 11 pi over 6 plus 2 pi n, where n is any integer.